Welcome to The Explainer. Today, we're diving deep into stunting, a massive global health crisis that affects millions of kids. Now, you might think the solution is simple, right? Just more food. But as we're about to find out, the real answer is hidden deep inside our own cells. Let's just start with a number, 148 million. That's how many children under 5 were affected by stunting back in 2022. It's a truly staggering figure, and it represents this kind of hidden pandemic with consequences that last a lifetime. So, what do we even mean by stunting? Well, the World Health Organization calls it a profound impairment of growth and development. And this is key. It's not just about a child being small for their age. It's a sign that their body and their brain have been fundamentally held back from ever reaching their full potential. To really get why this is so urgent, let's take a look at the sheer scale of the problem and the huge ripple effect it creates, an effect that, in the end, really does touch all of us.
The cost of stunting is just devastating. And it really does last a lifetime. You see, stunted children are way more likely to struggle in school, they earn less as adults, and they face a much higher risk of chronic diseases later in life. This creates this tragic cycle of poverty and poor health that doesn't just hold back individuals, it literally slows down the economic growth of entire countries.
So you'd think the solution would be pretty simple, wouldn't you? If the cause is malnutrition, then just provide more food. But for decades, that's exactly where this story gets really, really complicated. And this, right here, is the central mystery that has been puzzling public health experts for years. I mean, we've known about stunting. We've rolled out all sorts of programs. And yet, the problem just stubbornly persists in so many parts of the world. So why haven't our best efforts been more successful?
In fact, you've got studies from all over the globe that paint a pretty frustrating picture. In rural Gambia, even after 40 years of interventions, a stubborn 30% of growth faltering was still there. And in Ethiopia, a big review found that 2/3 of their nutrition programs had no measurable effect on stunting. I mean, clearly, we've been missing a huge piece of the puzzle. So, to solve this mystery, scientists are turning to this powerful new approach called systems biology. Instead of looking at things like nutrition or infection or genetics all separately, it looks at how they all interact as one big, complex, interconnected system, which is, the human body. Think of it like looking at the entire forest instead of just one tree at a time. So what is systems biology actually telling us? Well, it's revealing that stunting isn't just about a lack of calories. It's a crisis happening at the molecular level. It's a fundamental breakdown in the body's own blueprint for growth. Okay, let's start with something called the mTOR pathway. The easiest way to think about it is like the master switch for growth inside your cells. When that switch is on, your body builds proteins, it creates lipids, it grows. But when it's off, all that construction just stops. And in stunted children, this switch is often stuck in the off position. And this diagram shows us exactly why. See that mTOR-C1 complex on the left? Think of it like a lock. It needs 3 keys to turn on: energy, growth factors, and crucially, amino acids, the basic building blocks of protein. But in stunted children, the levels of these essential amino acids are consistently low. So without those raw materials, without those keys, the mTOR-C1 complex goes inactive, just like you see on the right, and the entire cellular factory for growth just grinds to a halt.
Now let's zoom in on just one of those amino acids, tryptophan. In a healthy body, it basically has 2 jobs it can do. It's at a fork in the road. It can be used for growth, to make proteins and serotonin, or it can be used for defense, to help fight inflammation.
But in children with stunting, chronic gut inflammation puts the body on constant high alert. This inflammation acts like a rogue traffic cop, constantly forcing that tryptophan down the defense path. That's the kynurenine pathway you see here. And as this diagram shows, that diversion starves the serotonin pathway, which is absolutely critical for both physical growth and for brain development. Okay, now let's look at another critical process, carbon metabolism. If amino acids are the building blocks, you can think of this process as the body's crew of tiny carpenters. They use things like B vitamins to build and repair our DNA and to regulate which genes get turned on and off. But this whole construction crew, they rely on a steady supply of B vitamins. And when those are missing, which is super common in malnourished kids, the entire cycle you see here just breaks down. And that leads to a buildup of cellular waste and an inability to create new DNA. Basically, the carpenters are out of tools, and construction just stops cold. This insight led researchers to a really promising idea
I mean, eggs are an absolute powerhouse of the exact nutrients needed for this cycle: choline, B vitamins, high-quality protein. So could something as simple as an egg a day be the solution?
Well, the results were fascinating, but they were also really puzzling. The first Lulun project was this huge success. It showed that one egg a day reduced stunting by an incredible 47%. But then, and this is the kicker, a follow-up a few years later found that those benefits just hadn't lasted. And other egg studies have shown mixed results too. This tells us something absolutely crucial. While nutrition is vital, there's no single magic bullet. There has to be another factor at play.
And that other factor is a condition called environmental enteric dysfunction, or EED. It's basically a leaky gut syndrome, and it's caused by constant exposure to pathogens from poor sanitation. EED damages the intestine, which not only stops the body from absorbing nutrients, even when you provide them, but it also fuels that chronic inflammation that we saw derailing all the other growth pathways. It is a truly vicious cycle. But what's really fascinating is that all these disruptions, the mTOR switch being off, the tryptophan being diverted, the broken DNA repair cycle, they don't just start after a child is born. A lot of the time, the problem begins much, much earlier. Research is now showing that about half of all stunting actually begins in the womb. As this diagram makes really clear, a mother's own nutrition and her health directly impact these critical metabolic pathways in her developing fetus. So if a mother is malnourished or suffers from inflammation, she can inadvertently pre-program her child for a lifetime of growth challenges before they even take their first breath. Okay, so what does all of this actually mean? Well, this much deeper understanding of the molecular machinery of growth, it lets us move beyond those simple, one-size-fits-all solutions and start designing much smarter interventions. An effective modern strategy has to be an integrated one. First, it starts with precision nutrition, right? Targeting the specific amino acids and vitamins we now know are missing. Second, it has to focus on restoring gut health to stop the leaks and the inflammation. Third, we have to reduce that inflammation at its source by improving sanitation and hygiene. And finally, and maybe most importantly, it has to be maternal-centered, making sure moms are healthy and nourished before and during their pregnancy.
For decades, we fought stunting from the outside in. But by understanding the body's broken blueprint at the molecular level, we now have a real chance to fix it from the inside out. So the question is no longer just how do we feed a child, but how do we rebuild their very foundation for growth? And in doing that, how do we finally write a new story for 148 million children and for all the generations to come?